Many years ago, over cosmic, exuberant jazz, legendary musician Sun Ra and his orchestra excitedly sang out over and over again, "Space is the place." Space is the place. Space is the place. They sound optimistic, energized, like they know something the listener doesn't, and that they're trying to let us in on the secret. So what exactly did they mean? Space is the place for what? Black holes, alien worlds, robotic exploration, fantastic expeditions, gardening? Yes, you heard that right, gardening. Ohio State is deeply involved in the next generation of space research, and the discoveries we're expected to make could soon have profound impacts down here on planet Earth. I'm Franny Lazarus, and you're listening to Now at Ohio State. We talk with researchers, innovators, and bold thinkers who look at our world, see what the real challenges are, and create the solutions that people need now. So before you start thinking about space crops and farming on the moon, let's begin slowly. Liftoff starts with a big picture conversation about space research at Ohio State and the partners joining us on this ambitious endeavor. John Horak is the Neil Armstrong Chair in Aerospace Policy in the College of Engineering at Ohio State. Additionally, he's a leading member of Ohio State's George Washington Carver Science Park Initiative and its fascinating Starlab testing facility. John sits down with our Tatiana Woodall to discuss the future of space research, the initiative itself, and how Ohio State is playing a major role in future space discovery.
So John, you're a professor in mechanical and aerospace engineering, as well as the Neil A. Armstrong Chair in Aerospace Policy in the College of Engineering here at Ohio State. You also worked at NASA, where you were responsible for advanced complex science and exploration research. Can you tell me about how you use that obvious passion for science and space to pivot from one public institution to another, and sort of what your work entails here now?
Yeah, so it's interesting. My appointment is both in mechanical and aerospace engineering and in the John Glenn College of Public Affairs, so it can be a very left brain, right brain kind of activity. I think the one thing that I would say that, I've had experience in NASA, in the space agency. I worked there for 17 years. I've also been in the private sector. I had profit responsibility at a company in Huntsville called Teledyne Brown Engineering, did that for 4 years. And then I was also the vice president for research at the University of Alabama in Huntsville. So when you have sort of academia, government, and for-profit experience put together, I hope that it brings a more wholesome perspective on sort of how space is done across those three domains. And can be used both to inform research so that it's maybe more generative of outcomes that either serve a national interest priority or take advantage of a national interest opportunity, as well as gives me some opportunity to work with students who might want to have a range of career paths and say, well, here's what I know about that because I have some experience here. Here's what I know about that because I have some experience there. And to try to bring a more holistic perspective to the activity of spaceflight and space research that we do, not only in the United States, but around the world.
I know you're also one of the main spokespeople for the George Washington Carver Science Park, a first-of-its-kind park devoted completely to science research. Can you explain what that program is and sort of its overall goals? Yeah,
so there's two pieces to the work that we're doing there with regards to the George Washington Carver Science Park. The park itself is an opportunity for Ohio State to build an ecosystem of human beings, assets, capabilities, laboratories, facilities, students, faculty members to fortify the growth of commercial research in low Earth orbit that will be coming following the retirement of the International Space Station in 2030. And we are working with Voyager Space as well as the Starlab program, which is the name of one of the space stations that will follow the ISS. Starlab is itself a joint venture between Voyager, Airbus, Mitsubishi, a company in Canada called MD8. The Carver Science Park is the ground ecosystem to fortify all of that work that will go on in orbit. It can be very high consequence to failure. You kind of don't want to get up there and say, oh, gee, wow, I should have brought a crescent wrench, right? I mean, those kinds of things need to be worked out on the ground so that when you get to space, you have as few surprises as possible. And plus, most people won't get to go fly in space. So where can you go to experience it as closely as possible and participate in it as meaningfully as possible? We believe that Ohio State is going to be one of the major places in the world to do that when it comes to research in low Earth orbit in 2030 and beyond.
Have there been any challenges that you foresee the park going through, and how do you see overcoming them?
Research in some ways is what you call doing when you don't know exactly what you're doing, right? Mm-hmm. Research can be very sort of self-guiding in the sense that the next question you ask is a function of what the answer is to the question you're asking now. So we will have all kinds of challenges, right? We will have technical challenges about, how do we fully leverage the spaceflight environment to improve human health, right? How do we leverage the spaceflight environment to build innovative new materials that we can either learn how to make in space and come back down and do on the ground or use in space? So there'll be technical challenges, right? We're coming into this new era where the intersection of government, commercial enterprises, and the university research environment is new. It's emerging. We see the influence of commercial space now through things like the fact that we launch astronauts to the space station on a commercial basis. The national security enterprise in the United States is relying more and more on commercial companies as opposed to building their own $2 billion spacecraft and operating them. And the question has to be asked, what is the role of a public land-grant university in that going forward, given that we are here to educate people for citizenship, to help solve national and global challenges and take advantage of the opportunities that are presented through our research, our faculty, our students, and our facilities. So there's a lot of innovation, and I think the list of challenges will be large, but I'm looking forward to them because if we're not encountering challenges, we're not breaking barriers, we're not innovating, and we're not moving forward. That's the definition of progress. Sort of, if you climb Mount Kilimanjaro, the fact that it's uphill makes you tired, but it also tells you that you're headed in the right direction.
Starlab won't launch until 2027, and you previously estimated that the park will be up and running mid-2028. So what's happening in the meantime to keep building momentum?
I think a more accurate launch date is probably near the end of 2028. What we're aiming for, Tatiana, is to have some amount of overlap between Starlab and the International Space Station so that you have both up at the same time so you can sort of transition from one to the other. But you don't want that to be too long, and you certainly don't want a gap. So what we have to do in the meantime is sort of begin to fill the pipeline of research so that we are ready to go the minute Starlab is launched into space. Different from the International Space Station, which took maybe 4 dozen, 5 dozen assembly flights, depending on how you want to count them, many of them from the space shuttle, but also from non-human launches as well. Station wasn't really ready to go for full utilization until long after, maybe 15 years after the first piece was launched. We can't do that in a commercial environment. So Starlab is designed to be what I'll call a ship and shoot space station. It's ready right out of the box. And so what we're doing now, even though we're in a temporary facility in the College of Food, Ag, and Environmental Sciences in the Food, Ag, and Biological Engineering department, is that we're beginning to seed the garden for research, if I can continue with the food and ag environment analogy. That is that, by the time you launch, we want some very ripe, robust tomato plants producing research fruit. And today we're putting the little seeds into little cups and watering them so that they can grow and be incubated on the ground and find their way to spaceflight activities. Now that crosses a huge dynamic range of research. I have a graduate student, Cassidy Brozovic, who's working on how to water plants in space. Another student, graduate student, Ed Louis, who's working on how to do cold welding in space. We just returned an experiment back to Ohio State that flew on a parabolic aircraft, or the Vomit Comet that people call it, to do zero-G welding in space, also in vacuums. That was the first time that was ever done. So there's an enormous dynamic range of research ongoing at what I would call the early stages to grow it and support that research so that by the time Starlab is in orbit, we're ready to go with flight experiments.
Taking that back to what you said about research fruit, can you tell me about why understanding and taking the time to invest in space research might be important to for Ohioans on the ground?
So space has become an essential element of life in the 21st century. From the time we wake up even while we're sleeping, to the time we go to sleep, we are using space 24/7, 365 to find our way around, to order Uber Eats, to your ADT system, connects to satellites. It's just incredible what space has done for us. And it, like clean water, clean air, reliable power, it's an essential component of the modern world. And so not only has it become as important as those things, it is also now becoming an extremely important research environment for us to learn about how to live better on Earth.
You said before that you believe humanity is basically already a spacefaring race, mainly because people have been in the ISS 24/7 since 2000. So can you tell me how you see the space industry continuing to evolve? And do you have any predictions about how big a spot, this program will play, or like I said, Ohio State will play on that stage?
So yes, in some ways, humanity has been a spacefaring civilization ever since there was civilization, because we all ride on a spaceship called planet Earth, and we're stuck kind of, 2/3 of the way out from the center of the Milky Way galaxy. We are spacefaring. Everything on Earth is spacefaring, whether we choose to look at it that way or not. I believe that to be true. The fact that we have had people on orbit 24/7, 365 since November of 2000, 24 years now, that's an amazing step forward for humanity, because now we not only go visit, but we live there. And so what I think you see is, as we push humanity out into space and we spend longer times in space, we actually integrate space more deeply into our lives on the ground, whether that's just by knowing or by having a sense of what it's like by being there, or leveraging the space environment for better communications, better drugs, better materials, better knowledge and insight, and understanding our place in the universe. Maybe the best thing we can do is use space to learn about our place in it, so we can all be better by being better to each other, realizing that we share the same planet, we drink the same clean water, hopefully, we have to breathe the same air, and somehow we got to figure it out rather than fight it out. Because the universe can be kind of agnostic about whether we're here or not. So let's be here.
John, thank you so much for your time and for joining us. I feel like I've learned so much from you today.
Tatiana, thanks. It's always great to work with you, and I look forward to doing many more things together with you as we push the envelope on low Earth orbit research here at Ohio State.
Okay. Consider this. Plants in space. Our next guest is studying exactly that. Cassidy Brozovic is a graduate student in mechanical engineering and agricultural engineering. Her research aims to better understand and improve plant growing operations in space, and how we can take those findings and utilize them here on Earth. Again, our Tatiana Woodall sits down with Cassidy to discuss her research, her unique passion, and what her work means for biology and botany here on land.
Cassidy, it's so good to talk to you again. Thanks so much for coming on today.
Yeah, absolutely. I'm happy to be here.
You're currently a PhD student in the College of Food, Agriculture, and Environmental Sciences, as well as a member of Ohio State's Star Lab, George Washington Carver Science Park team. At first glance, these seem like very different pathways. So can you tell me a little bit about how you've taken really unique passions and joined them into a blossoming career?
I did a lot of undergrad research here at OSU. I was in the same major I am in now, so food, ag, and bioengineering. But back then I was in something called ecological engineering. So I learned really early on that I really loved fluids through the stormwater stuff. I also got to look at a couple soil things. So I was like, okay, I like water and I like soil, and that's great. And then I learned about our Star Lab program and the involvement my department had in it. And it just sounded like something I've never really heard of before. I didn't know that space ag was a thing. And at first it was really overwhelming because I had didn't really feel like I had a place there. I was like, everyone's studying rockets and propulsion and nuclear and like all these like very traditional space things. But then I kind of found my little niche in the group of people who do this space ag, space biology, bioastronautics type of work. And I really just kind of fell in love with it. And the reason why I decided to stay with it was kind of one of those situations where I sat with it and I was like, do I want to do this for grad school, or do I want to take this job offer I have in stormwater? It was something that I couldn't quite put away, and I knew I would be mad at myself if I didn't explore it further.
Diving deeper into your Star Lab connection, what does the George Washington Carver Science Park program entail for students, and how can they get to interact or conduct research of their own inside the program's boundaries?
It just opens doors. Having a program like that at OSU just allows students who maybe are like me and had this small inkling where like, oh, space is actually kind of cool. Didn't know that there was a place for me in it. So now what do I do with that? And it's really kind of this place where you can foster that interest. People always say there's two things you got to tell a room full of kids to make them excited, and it's space and dinosaurs. And I think if Ohio State just emphasizes that we have space and we're a university for space, students will flock.
Why is growing plants in space traditionally such a difficult endeavor?
Anytime you get into the spaceflight environment, especially living things, but anything we take for granted here on Earth changes. From crystallization of different molecules when you're talking about materials. And then on the biology side, you have cells forming differently. So sometimes, here on Earth, we get ellipse cells, so it kind of looks like an oval, but on microgravity, it's a perfect circle. And that just doesn't form like we have here on Earth. When it comes to plants, though, too, there's some mechanisms and genes that we've been studying of like, what is the microgravity and gravity gene? How does the plant know to put its roots in the ground and the shoot up? And the root zone is where I'm kind of specialized in. And it's just so fascinating to see the shape and formation the roots take in a microgravity environment versus Earth. So you could see how are they planning to find the water and what changes when they get up there, when normally on Earth, it's got these roots can kind of find the water. They just kind of seek it out. But when your water is not in a traditional place that you've been bred for generations and generations to find, what do? One of the things that's been an issue this whole time is water delivery. So water itself acts very differently in space than it does on Earth. For one, it kind of globs up into a fun ball. And whereas on Earth, if we're talking about growing plants and watering them, you irrigate your roots and the water falls down and goes into our groundwater system. But in space, nothing falls down. They have these things called plant pillows, which is what they're currently using to grow the plants in right now. And it's basically this tarp-like tissue box structure filled with this clay material, and it's the same material you see on baseball fields. So that orange stuff on a baseball field, they pack it up and ship it up to space to grow plants. And in that plant pillow, there's one of two things that normally happens for making it really difficult. The first is that the water will find the root, but then encapsulate the root. And because of differences in buoyancy when you go to space and gas diffusion, it ends up suffocating the root because there's no oxygen able to get to that root at that point. So it kind of snugs it like a little sweater. And the second thing that happens is the water will find a corner within your plant pillow and pool there, and then the roots never have time to find it and they dry out.
You already said sort of what they do now, but much of your research actually revolves around plant container design. So can you explain why even minute details like that are vital to future space experiments?
What we're hoping to do is get to that level where we can have production scale so that astronauts can eat that food, mostly so that they can have that supplemental, nutritious, fresh vegetables. And the water delivery of the root zone is really where it all starts. If you can't get water to your seed, it will never germinate. And all these things we take for granted down here, you go up there and design anything and you're like, I had no idea that gravity was involved in that working. Just figuring out that getting water to the seed is exactly where I'm at right now, and trying to control the water movement so it doesn't suffocate it, but also so that it still finds it.
Are there any other advantages to doing the same kinds of experiments simultaneously, both on the Earth and in space?
Oh, yeah, absolutely. So that's always really important in any kind of research. You always want to have some kind of control. And we can kind of use that with, having a lab on Earth and then having a lab in space. So with that analog facility that we're working in, you can set up everything, make sure everything works. The only thing you can't turn off is gravity, and you can't turn on heavy radiation. So you can make sure everything works, everything plugs in, nothing's going to blow up when you plug it in, and that you're ready to go. You have your procedures for exactly the kind of environment you're going to be in. So you have your experiment here on Earth, and you're going to run the same exact thing that you then send up to space. And what that allows you to do is do a full comparison test. So what are the results we're getting here on Earth? And then what are the results are we getting in space? And then if they differ anywhere, it's okay, is it because it's in space as to why that's a difference? And that's where you can get your little bits of information of like, I had no idea that gravity was involved in that, but now I do, because it's very different than what I got down here. That's why it's really beneficial to have both your Earth asset and your space asset together.
Can you speak to how encouraging plant science in low Earth orbit might also be beneficial for agricultural advances on the ground, especially in Ohio?
Yeah, agriculture is a really big industry, especially in Ohio. You can kind of go 10 minutes out of any city and you'll hit farmlands. Space is super stressful for plants, and they kind of act like how plants act on Earth when they're sick. And if we're able to then, fix the plant up in space and make it healthy again and really strong, and then maybe also some of the seeds of that plant are different because they were in that microgravity environment and grew in that microgravity environment and were exposed to radiation, so maybe some mutations happened, but maybe they were beneficial mutations. We can then bring those seeds back down on Earth and have a strong crop, like really, really strong crop that is able to endure drought, which has been really important this past year in Ohio. Maybe you can have a plant that is able to adapt to extreme drought. Maybe a plant that can do extreme hot and cold. Maybe you can have a plant that grows in a more compressed manner. So maybe you want to have in controlled ag, that vertical farming aspect. Maybe you can have multiple rows of a crop like corn, which takes up a lot of space on a field, but maybe you can make it shorter through adaptations of being in a spaceflight environment and confined to the very, very small area you're given in space to grow plants. Maybe we can grow a corn in space that's really compact, really high in nutrients, and then we could take that seed from that plant that we grew up there and then bring it back down here. So if we can make a plant grow in space, we can make a plant grow anywhere down here on Earth. And that's kind of where I hit home with a lot of people. I'm working on water delivery for plants that might be grown in lunar regolith. Lunar regolith is basically moon dirt. And it does not, plants don't want to grow in it. It's not good for that. And it's basically like a sand, but a really, really fine sand. And if I can make a plant grow in that substance, then I can make a plant grow on Earth where there's places like, desertification happening and poor soil health. So that's kind of how it connects the two.
Well, Cassie, it's been a pleasure to talk to you. You've been doing and will be continuing to do some really groundbreaking research, and I can't wait to see where it goes.
Thank you so much for having me today. This has been an absolute honor and pleasure.
Thank you.
There's so much we've yet to learn about space. How water flows in a zero-gravity environment, how to grow potentially life-sustaining plants, and how to address uniquely human health challenges. It's abundantly clear that the future of space research is thriving, and it's exciting to know that Ohio State is on the forefront of these discoveries. So maybe Sun Ra and his orchestra were right. He knew. To sow a cosmic garden, space really is the place. Now at Ohio State is produced by The Ohio State University's Office of Marketing and Communications. For more information, visit us at go.osu.edu/now. I'm Franny Lazarus. Thanks for listening.